Hi there, welcome back to this build of a 40-inch wingspan iconic Keil Kraft Gypsy. Now this is a lovely design that was done by Bill Dean in 1949. Now you can see we've more or less got the superstructure, the skeleton of this plane finished, and we just need to start thinking about some of the more detailed bits. And what I want to do in this video is, well, for a start, I need to put in some dowels and attachments for the wing, because there's nothing for that at the moment, and that will also add a little bit of strength to the structure. But let me just get rid of this at the moment, stow it away safely. But the main thing I want to be looking at is the tail assembly, and I want to build in a Dethermaliser. Now this was originally a free flight design, but where I fly I need to be very careful that I don't leave the confines of the airfield. We're in a fairly restricted site, which is fine. So I'm going to have radio control, I'm going to have one channel for the rudder, but I'm going to have another channel that operates the Dethermaliser. And a Dethermaliser essentially is a mechanism by which to bring down your aeroplane quickly and safely. If it gets caught in a thermal, because these are very light free flight designs that will just disappear if you're not careful and will stay up there. Even though they are rubber powered, I've seen these go to great heights and get caught in thermals. So having a Dethermaliser I think is a really good option. And essentially a Dethermaliser is a mechanism by which you can tilt the tailplane to about a 45-degree angle like this, and it just stalls the aeroplane and brings it down, like I said, fairly quickly and fairly safely. So we'll have a quick look at how we're going to do that. And I don't know whether I said I'm going to operate the Dethermaliser with a micro servo. I'm going to have a cable network coming back to a micro servo around the CG point. I have got a dedicated Dethermaliser setup with a band burner, a more traditional kind of way of doing it rather than a servo, but the weight of this adds up to about the same weight as a micro servo. And as I've already got the radio equipment in there for the rudder, I may as well use a servo. It'll be a lot easier than having a transmitter to control the rudder and then also a separate unit to control the Dethermaliser. Far better to have it all as one, running off the one radio battery. So anyway, let's take a closer look at this and see how we're going to get this Dethermaliser built. Right, we need a mechanism by which we can trigger the servo and the tailplane goes up to about 45 degrees and is held there securely. We don't want it flying off. So the first thing I'm going to do is I've got a bit of balsa to put in the back of the fuselage, and that will not only provide a little bit of strength, but I'm going to put a slot in it so that the front of the fin can feed into that and it will hold securely. It will, if I just turn that around a little bit, it won't sort of wobble too much. Now I'm also going to have some elastic bands. Normally with this, you just get an elastic band. If you're going to hold the tail on, you would come over the top and you would come down to a connection point, a dowel down here. Well, I'm going to bring this connection point further forward to about here, and I'm going to connect the elastic bands from a midpoint around here, and so that essentially they pull. Let me just take that out before I do some damage. So essentially they pull the tailplane up into that kind of position. So that's good so far. That will just come up like that. Now the next thing we need to do is on the back of the tail here, we need to have a piece of cord that will allow it to not only be held down, which will be linked to the servo at the front of the plane, but we need to have that so it'll hold it at that point. it doesn't suddenly fly up like that. So it needs to allow it just a little bit of movement, so like that. And I'm going to use this polypropylene, I think it is, cord. It's really, really strong, very flexible. And I'm going to make a little bit of a tube in the back like this for the cord to run from this back point here to the underside of the fuselage, where the cord can exit and run all the way up the fuselage. Just move that forward, all the way up the fuselage to where there's going to be a servo. And the cord will just be on the servo, hooked over, maybe with an elastic band like this. You operate the servo and the band will just come off. So that's essentially how we're going to set this up. So I will start pulling this together and we'll have a look and see how it works. Right, a couple of points I thought it worth sharing. First of all, I've got that piece of balsa in now with a slot, so that allows that to come up nice and smoothly like that. And like I said, I'm thinking of putting a piece of balsa here, but I may not. I may just leave it at that. I'll see how it works. But the next thing I need to do is I want to make a piece of wire that comes through the tailplane here with a bit of a loop on it to attach the elastic bands to, that will pull down to the attachment point here and will cause that to lift up. Now, I've bent one piece of the wire. You can see the loop I put there, and I'm going to push that through the tailplane. But I just thought I'd show you these pliers I've got. They're rounded ended pliers of various different sizes, and they're for making jewellery, and they're really, really useful for jobs like this. So I can get an idea of how wide this piece of metal wants to be as it sticks through, and where my loop needs to go. And if I just hold it with the pliers like this, I can then, let's just think about how this is going to be, I can then just bend that around like that, and we've got a nice loop. I can even bend that a little bit further so it matches the other side, and then I can trim it off to size. But these kind of jewellery pliers are really, really good for this kind of job. Let me just there we go. And now that just needs trimming so that it matches the other side. It needs a little bit more bending, but I just wanted to show you these pliers. They're great for doing this kind of job. And I've got a pair of cutters here, and we'll just cut that and then just bend it a little bit more. But essentially we've got our clip with the two kind of loops on it. It needs neatening up a little bit, but that will go through the tailplane. Now on the back of the tailplane here, I'm going to install this little bit of aluminium tubing like this, just to run my cord from the servo. It'll hit the tube, it'll come up the tube, and then just to the back of the tailplane here. Now the next job I want to do is show you how, hopefully that's in focus, I've put a little bit of a bell end, would you call it a bell end? I've just flared it anyway, on the end of that aluminium tube. Now this is really thin aluminium tubing, very light, and I thought I'd show you how to put that flare on, that little bell. What I've done is I've bent up a piece of music wire like this, and I'm going to put that in my drill. There we go. So that's in my drill, and I'm going to use that as a flaring tool. So we just put this over the pipe. Now hopefully you can see there's no flare on that, and we'll just put this over. It might be better if I held it with a glove because it held more secure, but if I now just turn this, there we go. And we can see now, hopefully you can see the bell that's put on, the flare that's put on the end of that pipe. I hope that's focusing. I'm putting my hand there to try and provide a surface for it to focus against. Maybe it shows up better against that. But anyway, so a really good technique for flaring the end of your tubes. So I'm going to drill a hole down here now and install this in the back, slide it down in the back of the fuselage, like I say, so it comes out there just as a guide for the cord. Oh, and one final point, I need to be able to attach this cord to the back of the tailplane. And I could just drill a hole in the balsa or in the balsa on the fin, but it wouldn't be very strong. So I'm just going to cut out a little bit, 1 mil off the back of this rudder, or actually it's the fin, isn't it, because the rudder stops here. So at the back of the fin, and I've made this little bit of plywood with a hole in it, and that's just going to glue on there like that, and the back of the fin will come down, and it will just leave a little attachment point for the for this cable just as it comes out of that tube. So I'll get this put together now and we'll have a look. Right, I've now got the piece of aluminium tube into the fuselage, the back of the fuselage. You can see that's the flared end there, and you can see it goes from there down to the back here for the cord. Now that will have undoubtedly weakened the back of the fuselage. You can see that coming through there now. So what I'm going to do is I'm just going to put a little bit of epoxy on it, just put a little bit in the back there, but I don't really need the epoxy for strength so much as gap filling. So what I'm doing is I'm putting a little bit of balsa dust in there, and I'm just going to mix that up into a kind of an epoxy paste really. And I always save my shavings, or some of my shavings, and if we don't mix it up into a paste like this, when we put it in around the pipe, because it's so runny, it will just sort of run off it and won't fill the gap. But by mixing it up into this paste, it'll actually stay where we put it. So I will get this glued in. Like I say, I mean, this will weaken the epoxy a little bit, but you know, we don't need that kind of strength. It's just to fill the gap. I'm sure there are other things we could use, but it's kind of what I've got to hand, so that's what I'm going to use. So I'll get on and get this glued now. Well, as you can see, I've really been getting on with this, and for a start, I've got the wings held on now. Just really simple. I've put some dowels, and I've used some carbon fibre that I've got. I just thought that would be a little bit lighter and a little bit stronger, and that has just glued on. I used some epoxy because that will glue really well, not only to the balsa but the carbon fibre, and I've just epoxied that in. On the back here, I've just put some gussets and some holes for the carbon fibre to go through. But that's nice and secure now, and I'm really pleased with how that's worked out. Now, the Dethermaliser, you can see that I've got this now set, and it's set at the sort of activated angle, if you like. It's about 45 degrees, and it's held up with these elastic bands. I originally put the pivot points down here for the elastic, or the attachment point, should I say, for the elastic bands down here, but it didn't really pull it up very well. It wasn't particularly good, so I moved it up to here, and that works so much better. So we have the cord, which is coming from the back of the tailplane through the tube, and this will then come along the underside of the fuselage, and it will attach to a servo, a very small micro servo at the front here, and just with the flick of a radio switch, it will set the Dethermaliser like that. So it'll be like that for flying, and then we'll flip the switch and it will just go up and cause the plane to stall. Now, one thing I will do, I'm going to fit the servo when I do the electronics for the rudder, which is going to be interesting because the rudder is a movable feast, so we need to make sure whatever system we have with the micro servo just one of these really small 4-gram servos. Whatever system we have to operate the rudder, it needs to be flexible enough to cope with the dethermalisation or the lifting of the tailplane. One of the other things that we need to do is, the last thing we want is for the dethermaliser to go off and then this cord to be trailing along the bottom. So what I'm going to do is, shortly after the where it attaches to the servo, I'll have a little piece of tubing just on the underside or somewhere here that this cord runs through. So essentially you'll end up with just a very short piece hanging down, not the whole piece. And I may even have a bead or a knot that won't go through that tube, so we don't actually have the tailplane going all the way up like it is now. It will maybe just go to that point, something like that, rather than going all the way and banging up against the fuselage. So I thought it'd be worth having a quick look at the tailplane assembly, and you can see here we've got that piece of wire that comes through and the elastic bands just hook onto that. Now if we look at this side, we can just see the loop there, hopefully, that I made, and the elastic bands just hook onto that, but they can't come off there, so it's a really secure fitting. Now this bit of wire is loose at the moment, which isn't very good, so what I will do is, once I've done the covering, and I will cover the tailplane, I'll just zoom out a little bit. So I'll do the tailplane separately, and I will do the fin and the rudder separately, and then the piece of wire that goes through there I will put through and I will epoxy into place. At the moment there's just a slot in the bottom there where this can be threaded up, and I'll just take that out. I made a little bit of a mess. I wasn't totally happy with the slot that I'd put in, and if I can just get this out, it's a little bit tight, but better tight than overly sloppy. There we go. And so I've made a slot in there for that to just come up once this has been covered, because I don't want the metal in place while I'm covering. It'll just make it really awkward. So then I can just slot this in, and I'm going to epoxy around there and epoxy that into place, and I'll probably do that once it's actually fitted onto the tailplane. So that will just make life a bit easier. And we can see here I've got the cable attachment, or the cord attachment, just a piece of 1mm plywood. Well, it's really good to get this dethermaliser setup fitted onto this Gypsy, and I should add that this isn't part of the original Keil Kraft design. This is kind of an afterthought, something that I think is a kind of a sensible solution, or a sensible thing to do, should I say, because these things really can fly if you get them set up right. Despite being a rubber motor, they can get to quite a height, and if we do get caught in a thermal on a hot day, we're going to want something that will allow us to bring this down nice and safely, which this dethermaliser should do. They're not 100% foolproof, but they should do. I have heard of stories where people have triggered the dethermaliser and it stays up there, but hopefully this will work fine. So now we're going to draw this video to a close, and I need to start thinking about what I'm going to do next. What's going to be the next video? It will probably be the servos and getting this rudder connected, hinged up and connected to the servos, which, as I said earlier, is going to be interesting because we've got a movable rudder. So we can't have something like a carbon fibre rod, which I've been doing on some of my other vintage models. It's going to need to be a little bit different. There's part of me that quite fancies actually doing something a little bit different and covering the wings next rather than doing the servo, but I'll have a think about that and we'll see. I am looking forward to getting these wings covered, and in fact the whole fuselage, and I'm going to be covering this with laminating film and then tissue on top, like I've done with my previous, or a lot of my other vintage models. So anyway, we'll have to wait and see. But I hope you've enjoyed this and found it interesting setting up this this Dethermaliser. So thanks very much for watching, and please come back and see how we get on in the journey of kind of pulling together this lovely iconic Keil Kraft Gypsy.